So I'm really happy Rida accepted to be here today to give a talk about DDoS attacks. Rida is a full professor at Telecom, and I'm sure some of you in the room know him already. So Rida, the floor is yours. Thank you.
Okay, ladies and gentlemen, good morning. Today I would like to talk about the distributed denial of attack, impacts, detection methods, and advanced strategies. I am a professor in influence department in LTCE laboratory, and I work on the cybersecurity, the design and of security solutions and security protocols, and work a lot on malicious behavior detection and cyber attacks detection in wireless network, and especially in connected vehicles detection.
Demande de parler plus fort ou
Plus fort?
plus proche.
Ah bon?
Le son de l'extrême, il passe pas en retard.
I will repeat the question. So, okay, today I will talk about the cyber threats and their motivations to launch DDoS attacks and other kind of attacks. The distributed denial of service types impacts on the companies and on the infrastructure, and the actual detection solutions deployed in the internet, especially the anti-DDoS solutions deployed in the ASP. Talk about the technical and scientific challenges to developing detection method, and I will then talk about our approach to detect the DDoS using the artificial intelligence through the adversarial network neural. So first of all, here we can see the involved in Ukraine and Russia conflict, and we can see the different techniques, tactics, and procedures, like the phishing, the vulnerability exploitation at the servers and servers. Oh, okay.
I only hear you through
I will be okay. Okay, maybe it's better like that. Okay. So we can see the techniques, tactics, and procedures like the phishing, vulnerabilities exploitation, and also using the artificial intelligence to launch cyber attacks. And we have a lot of botnets and activity groups to launch the attacks. Like the distributed denial of service. And what are the cyber threat actors? We have the activists, the hackers, and the insider threats. Because when we talk about the cyber attacks, we talk also about the insider threats, because we cannot consider that all of the employees or the internal users are benign. And we have also the terrorist groups which launch attacks against the infrastructures, like the SCADA systems or like the internet servers in general. Why these adversaries or the cyber attackers launch this kind of attacks? It's for different reasons, like the authorities, the political statement, and we have seen a lot of attacks due to the political statement, like the attack in 2007 in Estonia, launched by a Russian group. And we saw also the attacks in against the Iranian nuclear center, and a lot of other kind of attacks for just for distractions. And actually, we have DDoS attacks with a huge bandwidth, using, for example, 7 terabit per second to attack servers, which will impact the destination server, and also which impact the ISP network, and not just the destination server. So the targets of this cyber threat can be the government networks and the critical infrastructure networks, like the water cleaning center, like the airports, and the nuclear reactor. And also, relying on the statistics, we can see that we have a lot of small companies attacked by the cyber attacks and the denial of service attack. And these attacks are realized using botnets of any kind of IP equipment. Can be the servers, laptops, and also the IP camera and the connected vehicles. So, for example, for the IP camera, in 2016, a botnet of 400,000 of camera was used to launch distributed denial of service against the DNS servers. And also, actually, we are seeing a lot of connected vehicles infrastructure deployment, and we can also, using the connected cars, to launch attacks against the infrastructures, or launch the attacks against the vehicles themselves. The different attacks used to against the servers and the infrastructure can be using the phishing, the exploitation of vulnerabilities, which is not so complicated with the deployment of all the exploitation code on the internet, and with also the deployment of exploitation code of the vulnerabilities published by the MITRE organs in the United States. And we have also the attacks on the mobile devices using the infected application, and also the distributed denial of service, which is an old attacks. And actually, we have this attacks is very dangerous. And what we mean by distributed denial of service? A distributed denial of service attacks is an attack generated by a large number of machines, usually infected by some malicious software, and all these machines will be categorized by some group called the botnet, and controlled by an attacker with some distributed architecture, not usually a centralized architecture. And in a coordinated manner, the attacker will launch the attacks using different kind of protocols. For example, we have the sign flooding attack. The sign flooding attack, the infected machines will send a lot of semi requests to open a connection on the servers, and we can also use the UDP flooding just to attack the bandwidths, not just to attack the internal resources in the at the server. And as we can see here, about the statistics, flooding attacks is represent the most launched attacks, and actually we are talking about multi-vector attacks where we can use different protocol like the TCP launching the signal flooding attack, and also HTTP attacks at the application layer. And this is why what we saw in the Estonian attack, the attack on Estonia in 2007, where different kind of protocols were used to attack the government servers.
Question. So what's the point of using TCP, which is
Okay.
self-reacting to assist isn't UDP much more natural to?
No. When we use the the DDoS attacks, we attack the bandwidths of the network of the server or the internal resources of the server. When we attack the internal resources of the server, we use the signal flooding attack, because when we send a connection request to the server will block some memory for this connection. And in this case, we attack the internal resources. However, if the server is well protected, we cannot do this signal flooding, and we can do the attack launching ICMP flooding or UDP flooding. And in this case, we attack the bandwidths independently of the internal resources of the server. And with the cloud computing, launching the attack is more easy than before. And as we can see here, on the dark web, we have a lot of offers to launch the attack, cyber attacks, and we can pay, for example, for 24 hours, and then we can use a ready botnet to attack any server or networks. And here we can see the distributed denial of service at the network levels. As you can see, we have different operating, different autonomous system, where we have a lot of infected machine called botnet, and through different botnet like the Gafit or Mirai, we can attack the server, and the server will not be able to give the normal service to the normal users. And I put this this image to because the solution against the DDoS will be based at the ISP level and not just at the server level. And here we can talk about the scrubbing center, where the ISP will deploy the anti-DDoS solution at this network of edge routers and internal routers, because just detect the attack at the victim level will not be efficient, and all the traffic will pass through the ISP level. So the solution will be in coordination between the destination network and the ISP level. We just for some cyber attacks like the DDoS attacks in 2007, I already discussed about that. We have the DIN attacks. the DIN attacks, it was an attack using the IoT devices like the camera in 2016, and the idea was very easy, is to look for IP camera using the default password, and then infect the camera to launch attack like the scene attack and ICMP attack against the DIN server, and a lot of servers were impacted by these attacks. The different DDoS attacks are actually volumetric attacks, and these attacks becomes increasingly powerful in terms of botnet architecture and in terms of volume, and in terms also of furtivity. The multi-vector attacks are becoming more frequent. We can use different kind of attacks like the HTTP flooding, SYN flooding, UDP flooding, and all the services, the targeted services are usually the web server or a DNS server. And relying on some statistics, we can see here that the duration of an attacks, the average can be between 2 and 6 hours, and which can be very dangerous for a company. And these DDoS attacks will have an impact on the business, like the revenue loss and the loss of customers, and also we will put a lot of resources in order to detect and mitigate the DDoS attacks, because all the solution used actually by the ISP in the scrubbing center use automatic response and manual or human resources to stop the attacks. And relying on Arbor Networks study, we can see here an estimation of the impact of DDoS cost, an impact and the cost of DDoS attacks. We can see here that an attack DDoS cost a business about $6,000 per minute. And we can also have cyber attacks for 24 hours, for 84 hours, and for 1 week. We can have an attack for 1 week. So you can imagine the cost of DDoS attacks. According to Cloudflare, DDoS threat report in 2024, for information, Cloudflare is a very famous solution against the DDoS attacks. Relying on these statistics, we can see that the Cloudflare protects about 24% of the websites, and Cloudflare autonomous system blocked 21 million DDoS attacks in 2024, and with a hypervolumetric attacks of 1 terabit per second and 6 terabit per second. So you can here imagine the complexity of detection, especially when we have a traffic attack that is like the normal attacks. And here the difficulty is to filter and mitigate the DDoS attacks. We have a lot of solutions, as I said, for.
Could you say a few words on that? So where is this Cloudflare software installed, and so how does it operate?
So not just the Cloudflare, all the anti-DDoS solutions are deployed at the destination network and at the ISP level. At the ISP level, we talk about the scrubbing center, which means that all the traffic destinated to the victims will pass through the data center, so scrubbing center, to filter the traffic and then re-inject the traffic in the network. So it at the ISP level, not just at the company. And actually, the company pay to have this service from the ISP about the detection.
So there is a contract between
Yes.
the company which is targeted
Yes.
and the ISP.
Yes, yes.
Okay, it's like taking an insurance, right?
Yes.
So you don't know if you feel that you may be attacked
No,
as a company, and then you make a contract with the
yes,
ISP to
yes.
install the
Instead of deploy our solution, I can for example, pay to have this service from the Cloudflare, for example, or other provider, Arbor Networks, for example, and I pay relying on what bandwidths I need to reserve to reserve. Yeah. Okay. And to evaluate the anti-DDoS detection solution, we have a lot of criteria, like the detection criteria, for example, which level of detection the solution can detect at the application layer or at the for layer. The mitigation capacity. This is very important in order to, if we have, for example, a big company like, I don't know, Facebook or other websites, we need a solution with a high capacity of mitigation. Another criteria is the automation, because when we have an attack, we need to deploy a solution directly in real time, and in this case we need a very small latency for what we call the off-ramp and on-ramp. It means when we have the attack, all the traffic will be sent to the scrubbing center, and then we re-inject the traffic, which is mean the off-ramp and on-ramp type. Also, the complexity and deployment cost. When we have a distributed denial of service, the response or the detection is not fully automatic. So we need some human resources to add some signature for the rules to detect the attacks, and also the last criteria is the resilience of the solution to support a lot of attacks at the different level. Here are the solutions just for the scrubbing center, because it's the most important one. The idea of the scrubbing center for all the solutions like the Cloudflare or the Arbor networks, in case of attack, all the traffic directed to the target address will be rerouted to the scrubbing platform, where we will detect, it means identify the DDoS using a lot of algorithm, and then redirect the traffic to the scrubbing center. And after that, we separate the legitimate traffic from the malicious traffic. and then we re-inject the legitimate traffic back to the client. Here we have different kind of stress and weaknesses, but the scrubbing center is the most used solution for anti-DDoS. A solution to develop a solution for DDoS attacks. We have a lot of challenges, scientific and technical challenges. First of all, the similarity between the attacks traffic and the normal traffic. Second, the volume of the traffic. We are talking about some terabit per second, and also the attackers adapt their attacks relying on what we have as a detection method, and the architecture of the botnet are actually very secured, and the using different using distributed architecture for attack, using different kind of attacks with high volume is very complicated to detect. And the detection is not just the challenges. However, the mitigation and the traceback is another kind of problem, which means that how can we go back and find the sources of the attacks? And this is a problem because we don't have actually a collaboration between the ISP for different reasons. And some solution for DDoS attacks stop the attack at the ISP level, but not at all the ISP from the source to the destination, because we don't have technical collaboration between the ISP. And in order to go back to the sources, we needed to pass through the different ISP, which is not easy because of the politics of each ISP.
I'm trying to understand the scrubbing center that you alluded to. So, I mean, two questions. I mean, so this is part of the contract. That
yes.
Right. So the one which deflects identifies the attack, deflects the traffic, then screens it.
Yes.
And sends the
traffic to the.
And so without the idea to separate legitimate messages from easy to put things into two categories.
Yeah, it depends of the type of the attacks used. Actually, we use a lot of artificial intelligence algorithms to differentiate the legitimate attack and the normal attack. But we have a lot of problems because of the volume. And next, or the second one is that the attackers can use the artificial intelligence in order to not be filtering through the scrubbing center. And I will show that using the adversarial neural network, where we can mimic, for example, the normal traffic, and then we can arrive to the destination without filtering by the scrubbing center. So we have a lot of statistical algorithm and artificial intelligence algorithm used to filter the traffic.
But so it's not on the fly. So you
yes.
have to do some analysis, and then after some delay,
yes.
sort out things as
legitimate
or not.
If we look to the solutions and the offers, we can see that it's in real time, but in reality, it's not in real time. The algorithm need some time to learn, and then we have also the human, we have the engineers that will analyze the traffic and then add some rules to the algorithm to filter the traffic. We are talking about the artificial intelligence methods. We have seen a lot of machine learning based intrusion detection system. The idea is easy, is to extract the features from the traffic and to detect and to and then use some machine learning algorithm to train the model on DDoS attacks and benign attacks. And we can have very high accuracy, but the problem here is with the generalization of the solution. The algorithms are often trained on a single dataset, and when we change the dataset, the performance will decrease. And also another kind of problem is the using of adversarial machine learning by the attackers. And in this case, the attackers can adapt the attacks to bypass the detection. We worked on the adversarial network, generative adversarial networks to do the same, and then to use the GAN networks to detect the attack DDoS, and we have this. We have published that in the Computers and Security journals. The GAN composite, in fact, of two models of a generator and a discriminator. The generator is used to create similar data, like the dataset, and the discriminator is another model used to estimate the probability to the sample to be in the real dataset or the fake. And here we have a kind of a game theory and a game between the generator and discriminator, and the generators try to maximize the probability of the discriminator to consider the sample from the generator and not from the real data. And in this case, we have perturbations on the AI algorithm. We have incorrect classifications and high effective in misleading malicious machine learning algorithm. So if we look to the attack model, the attackers enhance their strategy using the machine learning, and we can masquerade as normal traffic to evade the detection. So in this case, the avoiding the detection, still achieving the objective of the attacks, and the machine learning, the classical machine learning techniques will not be efficient to stop the DDoS attacks. Even if we stop the DDoS attacks, we have another kind of problem, which is the traceback and to know where are the different sources of the attacks. So we need to enhance the detection mechanism in order to detect the attacks that use the artificial intelligence and not just the classical DDoS attacks. If the attacks use the classical DDoS attacks. In this case, the actual solution will detect most of these attacks. But if we use the artificial intelligence to generate DDoS traffic, which is similar to the traffic, the normal traffic, in this case, the actual solution, even with the machine learning algorithm, will not detect the DDoS attacks. So we analyzed a data set proposed by the Canadian Institute of Cybersecurity about the DDoS attacks using 80 traffic features and 12 attacks like the TCP attack, UDP attack, and the ICMP attacks. And then we create a generator, a GAN generator, to generate the DDoS sample machine that closely match the DDoS instance from the dataset. And then we modified the values of the features that we selected in the generated traffic in order to change the similarity between the benign traffic and the attack traffics. And we then generated a data set from the classical data set and the generated data set with the GAN. And we train the model on the new data set to detect the fake attacks, the fake traffic, or the generated data. And the idea is to simulate what we call a scrubbing center, but with using the GAN method and not just the classical machine learning method to detect the attack. So this approach is to test the capacity of GAN in the generation of DDoS traffic and in the detection using the GAN. So for that, we real data.
This is encrypted data.
No, it's not encrypted. It's the real traffic. The real traffic generated by the different machines here, and like the ICMP packets by the sign flag.
In the scrubbing mechanism, because you read what is inside the data.
It's another problem because when we attack, usually we don't need to encrypt. We can attack just to attack. So we just use the classical traffic, and we don't need to encrypt. HTTPS and sign request, and also the UDP messages. And for that, we need to understand the relationship between the prediction model and the inputs. For that, we use the Shapley additive explanation, we call the SHAP, in order to know what are the impact of the features on the prediction. And with SHAP, we can choose the best features that impact the prediction. And in this case, the these features act as DDoS functional features that will be controlled by the attack model to avoid detection by the intrusion detection system. And in how it works, we generate the sample, the samples similar to the real data, and then we will calculate or estimate the probability distribution of the real samples, and the sample can be real or generated, and the discriminator will be trained for that, and then the generator and the discriminator will play what we call min-max game, and the generator will the objective of the generator is to maximize the probability for the discriminator to consider that the sample is not from the real data. And here we have to improve the loss function LGD, which represent the value of the loss function. And the discriminator and the generator are both functions represented by multi-layer perception in the neural networks. After applying the CHAP, we collect all the features that impact the prediction of the system, and here we can see the different information from the headers of the packet, like the mean packet length or the destination port, and so on. And after this, the result of the CHAP, in order to correct the errors, which can be back propagated from layer to another, we use the LSTM networks. And in the LSTM networks, we can, for example, take into consideration the history with some coefficient by using the forget gate and the coefficient for the history, and this is a method used to preserve some coefficient for the history. And however, if we use the GAN, we can generate the specific collection of data. However, we only produce the set of data, and it will not be easy for discriminator to give the good results. For that, we used another variant for the GAN, which call the Wasserstein GAN, where we will use with the generator a score indicating if the sample is real or fake for the generated data. And using this WGAN, we will give some adversarial data that follow the DDoS distribution from the input dataset, and then we can evaluate the generator using the similarity scores. And then we compare the cumulative sums per features. For each features, we compare the cumulative sum to see if the generated data is like the normal data from the dataset. And here we can see the cumulative sum by features, and you can see that the adversarial samples are valid and follow the same statistical distribution like the real samples. And here with WGAN, we can generate the normal traffic, and also we can generate the DDoS traffic. And here for the architecture for the IDS, the intrusion detection system. We have the dataset. We use different layer with the activation functions, ReLU, and then we before applying the machine learning, we pass through the LSTM, and the WGAN model will mimic the statistical distribution of the real traffic. And the adversarial sample can be used to evaluate the IDS. And as we can see here in the results, that the LSTM give very good accuracy or F1 score, not like the classical machine learning. And the adversarial neural network-based IDS using the LSTM and the GAN is represented by this architecture. We have because an IDS, classically an IDS is composed of an decoder, an detection engine, and alert system. And here we have the features encoder using the chap, the detection engine using the LSTM, and the WGAN, and the alert system. And without perturbation, without using the WGAN, the IDS was able to classify all the traffic. And with perturbation using the WGAN, we can see some decrease in performance using the our IDS using the GAN. To enhance the security against the perturbed DDoS, the GAN can be used, but we have to update the architecture with two models. The first one is to prevent the perturbed traffic from fooling the IDS, and we have to train the model on combination between the dataset, the original and the fake dataset. And then we, the model 2, we can block the abnormal traffic and we forward the benign traffic to the target system. So here we play the same role like the solution in the scrubbing center. And as results, we can see 95% correctly detected as fake, and 88 correctly detected as real data. So the actual DDoS attacks are faster, more sophisticated, and multi-vectors. And the botnets are secured and decentralized and distributed on all the ISP. The best solution used actually is the scrubbing center with artificial intelligence algorithm, but using the GAN or the artificial intelligence algorithm by the attackers, we can avoid the detection. And we need a solution that use the WGAN to be integrated in the solution deployed at the internet service provider, and what we call the next generation scrubbing centers, where we use the AI-based scrubbing center, and we don't impact don't impact the networks of the ISP, and also not the users or the destination or the destination servers, for example. And this next generation scrubbing centers will be reached by using the different advanced GAN Perfect. Okay, I think it's all. If you have questions.
Slide 24.
I have a question, if I may. I am on the bridge.
We have another question in the room. Just 1 minute, please.
I think everyone can hear me.
Yes.
So when you talk about the generator and discriminator, you told us that they use game theory over. And what type of game theory?
With type of game theory, it's in fact a method which use it to minimize the probability. I don't know the name exactly of the method used here, but the idea is to maximize the probability for the discriminator, and if the probability for the discriminator for a sample to be in the real in the fake data is high, and in this case the discriminator will not do the good job. So here we will still in this stagnation until the generator will enter the discriminator, will find the good classification to put the sample in the real traffic or the attack traffic. So this is the idea of game theory.
I have other questions. At slide 22. Okay. Yes. How much time takes the detection average, and how much time takes the decision to what we detected, find a solution?
So here we are talking about some minutes to define the signatures and to re-inject the traffic in the network. We need I don't know exactly, but because it depends of the solutions, and this is a criteria very important for the solution. But I can see that it's dozen of minutes. It's not in real time. It's not in real time. Yeah.
And last question about slide 13. Okay, so just curiosity about the composition of these $6,000 per minute. What is taken into account to say that it is?
Here, I think in this study, they take a website to website, and then we estimated that by the number of orders on the website. So if we, for example, the website will shut down, we will the company will lose, for example, some number of orders estimated at 6,000.
So, some question. What are the companies that you consider for this?
I think you can find that.
Thank you very much. Okay, that's all. Thank you very much.
Thank you.
C'était Marc Olivier, on est ici.
Oui, yes, Marc Olivier.
Yes. So my question is, so if I understood well your presentation, the goal is to train, say, a system to attack other systems. And so I was
Yes.
wondering, what is the motivation to do that? Because you are basically building weapons.
No, the idea is to generate a traffic attack and then to detect this traffic attack, because when we generated the traffic attack, we created a new data set using the generated data and the real data set. And when we combine that, we then applied the detection method on all the data sets. So we have generated in order to have a big data set, and then we applied the detection algorithm on this full data set.
And there is no public traces of previous outages that you could use to train your algorithms?
I didn't understand what
I guess that some attacks have been documented, and so there are maybe traces to reproduce the attack, or also there are tools that are here to ease the life of hackers to reproduce an attack. I'm thinking to Hermitage, for example.
We have used the data set that I present, which published by the Canadian Institute, but we added our data set to our sub data set to the data set because in order to show that using the classical machine learnings, when we have a data set generated by the GAN, the classical machine learning algorithm cannot detect the attacks. So here the solution proposed is to detect the generated traffic and also the real attack traffic.
Okay. And don't you think that, my last question is maybe a more philosophical question. So often the neural networks tends to capture the first momentum of something. And so don't you fear that malicious packets or attack scheme could be hidden in a larger communication that make hard the detection thanks to a neural network?
Maybe, but we have to test that. I cannot say
Okay.
a priori.
Okay. Thank you.
Thank you.
Francesca a une question.
Francesca, please.
Hello, no, it was not a question. I was writing the question.
Okay. Thank you.
Thank you very much.
Thank you, Francesca.
Approaches with or without the fake traffic in the trade.
Yes.
So did you compare against real?
The real data.
Real ideas that
we don't have the results of the scrubbing center evaluation.
But if you submit DDoS detector, systems can make a collection of autoencoders to work better or worse than this, right?
I cannot say if it will work better. We have to evaluate that and compare the results with what we have here.
Thank you.
Okay.
So, nice talk. I'm
Thank
not
you.
at all from this field, so my question might be quick. So you mentioned somewhere that this agreement between the ISP and the server is its cost.
Yes.
It's dependent on type of attacks against which you want to protect. So the question is, we assume that we know all types of attacks that might happen, and how do we manage the new type of attack?
The problem is not in the detection of the attacks. The problem in the trace back. The problem is to go to the sources of the attack. And in this case, we have the problem of coordination, of no coordination between the ISP. But for the detection, no, all the solutions deployed at the ISP can detect the attack. But the no coordination will prevent the victim to the victim ISP or the victim network to know all the trace or the trace back to the sources. So it's for the mitigation and for the answer, and not for the detection.
ISP can protect against the attacks with known.
Yeah.
What happens if there is a completely new type of attack?
So if we, it depends on the artificial intelligence algorithm used by the solution to evaluate if it's a new attack or not. So for that, we all the solutions, all the companies deployed this solution are actually working on the developing on artificial intelligence algorithm to differentiate between the legitimate and the normal traffic, and this is a very hard problem because if we look to the packets independently, we have the same packets, but the problem is in the time of launching these attacks and on the type of the attacks of if we exploit, for example, vulnerabilities or the resources on the destination or just for the bandwidths.
Second short question. You mentioned that the Wasserstein model can simulate the statistics of real traffic. Can you qualify this statement?
We can use the WGAN to generate traffic like the normal one, and we can use it to generate DDoS one. So we can use it in both case.
Is there a notion of accuracy of the statistic, or we don't know a better model, or what does this statement exactly?
So here we evaluated it just for the abnormal traffic, for the attack traffic, and we got the high accuracy, but with the normal traffic, we didn't evaluate that.
Thank you.
Okay, thank you.
Thank you.
Thank you.
Thank you. Bye-bye.